Hey, welcome everyone. Good morning and good evening wherever you are located today. And thank you for joining our first Virtual Developer Days. It's a great honor to have you all. So my name is Nicklas Wagerth. I am the NSO Community Lead. I'm also responsible for the ecosystem strategy, including NSO Developer Hub and NSO and DevNet. On my side today, I have Omar Sultan. Omar is leading the NSO Product Management team, and he's also my manager.
Hey, folks, just wanted to say a quick welcome to Developer Days. The teams worked really hard on pulling together the great agenda for the next couple of days. So take advantage of it. You're going to hear about some of our customers, what they're doing, how they're helping their business. You'll hear from us in terms of plans, and I really encourage you to reach out to folks and kind of co-create what comes next in terms of automation strategy.
So to set the scene, the purpose of having the community and this event is to make your network automation a smooth journey. And I'm proud to say that we have more than 6,000 unique visitors checking in on our Developer Hub every month, sharing experiences and collaborating. So it's really important that we have this meeting and that we're able to connect today. So since we are not able to meet in person these days, we have chosen the Cisco event app to engage. And in here you will find an agenda. You can make it up to your own personal agenda, and you can see your local times in here. You will also see a speaker list. You can check out more information about each speaker. You can check out the sessions, and there you will find a poll and a chat box where you can ask your questions to the speakers. You will also find an attendee list here, as well as games and partner information and an event survey that we want you to complete after the event. A few things to double click on is that it's important that you have this app downloaded and log in. And for that, you use your email and the confirmation code that you got when you registered to the event. When you logged in, you update your profile and make sure that you opt in for the attendee list if you're good with having your name visible. This makes it easier to connect with other attendees. And last, engage. Check out the agenda, click on each session, and here you will find more information on each speaker. You will find the poll, and the poll will go live when the session starts, and you will find the chat window there. This is where you will ask your question, and our moderators will read questions here to the speakers. So we have divided up this into 3 different sections, and we begin with the first. This is the one where we have the overview presentations from our speakers. Then we go into a live track section. Here you are supposed to select your favorite track and log on to a WebEx meeting. After that, we have hours of on-demand content that you can use and check out. After that, we'd like you to fill out the event survey. And with that, I'd like to hand over to our first speaker, Jonathan Davidson, who will shed some light on the key aspect of the future internet. So let's give him a warm virtual applause.
Hi, this is Jonathan Davidson, and I'm very excited to be here with you today at our virtual NSO Developer Days. I have some exciting things to share with you. Overall strategy for our mass scale infrastructure group here at Cisco, and the criticality and importance of automation to our customers who are building out critical infrastructure across the entire world. So let's go ahead and jump right in. You all know that connectivity is critically important. In fact, it has been shown over the last few months how important what all of you do is even more essential than ever before. You help keep people together, you help keep people connected to their applications, to their services, to their businesses, you help governments run, and this is only going to get exponentially more important over the next several months, quarters, and years. We have a whole set of new opportunities in front of us to completely transform how we can connect with each other through these types of collaboration apps, through these virtual connectivity days, and through a whole new set of experiences like virtual happy hours and virtual birthday parties. And what this means is for us, we have a whole new set of people joining this virtual workforce than ever before. And they need more connectivity to their homes, to their things. And this is something that we at Cisco are very focused on. So what I want to share with you is how we are transforming ourselves to help you transform your businesses for the future of the internet. Now, we know there's a whole bunch of different segments and silos, from the Internet of Things, new emerging technologies like Wi-Fi 6 and 5G. We know those applications need to be secured. We know that our data needs to be secured, and we know it requires a whole new set of silicon and a whole new set of software, both for enterprises, small, medium businesses, service providers, and of course our web and hyperscale customers. And what this means is we actually have transformed our leadership team in engineering here at Cisco to help this future come to life. Starting off to your left, Todd Nightingale is now responsible for the majority of our enterprise business, inclusive of data center, campus, wireless LAN, the Meraki business, and more. I'm responsible for our mass scale infrastructure. So everything that we build around mobility, optical, cable, routing, automation, and optics for all of our connectivity products. Liz Santoni now leads our emerging technologies and incubation group, which actually, beyond just being the CTO organization underneath her, she's going to incubate new technologies for Todd and myself and this round bubble that we're calling TBH, that's going to be leading not only our security team, but also our applications portfolio, inclusive of what's happening with WebEx, inclusive of what's happening with application dynamics, and of course, BroadSoft. And of course, last but not least is Eyal Dagan, who leads our silicon and our systems team, and he builds those products for both Todd and myself. These are the new 4+1 TBH engineering leaders that report directly into our CEO, Chuck Robbins, and we're part of the overall leadership team for the company. Now, pivoting over to the strategy for what we see as some of the major impacts for mass scale infrastructure is what's happening with 5G. And we like to think about our customers having really three big decisions to make in relation to 5G. First of which is the need to actually build a new core, moving from a 4G EPC to provide that subscriber experience, now needing to move into the 5G world. And many people are moving to 5G NSA, and then longer term, they'll be moving to a 5G SA deployment. But that's a critical decision to be made. You all have heard about the massive amount of bandwidth that's going to be coming with 5G. And because of that, not only do you need to replace the radios, but you need to replace the entire transport IP and optical infrastructure as well, which we're calling the Converged SDN transport network. And then third, the decision needs to be made is this whole new radio. Obviously, that is a big multi-billion-dollar decision for many of the largest service providers in the world around radios. And are they going to go down the traditional locked-in path, or are they going to go with a more open path where we can actually open up the last closed part of network infrastructure for our entire way that we build infrastructure today? Optical is open. IP has always been open. The radio is a closed interface, and that's one where a lot of companies are working on O-RAN and vRAN and how we can get that radio environment to be a more open environment. All right, so let's dive into each of those 3 decisions over the next few minutes here. So first of all, decision number 1, we have moved over the past several years from selling appliances for subscriber management software to selling virtualized software, and now we're selling cloud native technology. Now, what does that mean for you as a user? Well, what it means is that in the past, if you wanted to purchase subscriber management software from your vendor, you got the system and you got the software, and it was included as an integrated bundle. Now, we have a number of customers in the mobile space that have moved from that appliance to the virtualized software. In fact, one of our larger customers has over 70 million consumer subscribers running on our virtualized software, the largest virtualized software subscriber management deployment in the world. We also have customers that are now moving to cloud native technology. Now, what does that mean for our customers? First of all, is significant operational benefits. So instead of upgrading the entire software stack, you can just upgrade the piece of software or the microservice that needs to be upgraded. That means less downtime, that means less churn in your customer base, it means happier customers. And who doesn't like happier customers? The second big advantage towards moving towards cloud native and 5G, but this also applies to 4G as well. In fact, we're shipping both our 4G and 5G core that has a separate user plane called CUPS from the data plane. All right, so control plane is separate from the user plane, the data plane. Now, what are the benefits of that? The benefits of that means that you actually can move the user plane closer to where the humans actually are, or the things actually are. And this gives you significant benefits for being able to then move your CDNs out further to where those users are as well, which gives you 2 side benefits. One, it lowers the overall cost of deploying the infrastructure because you don't have to buy as much backhaul technology from companies like Cisco, but you also get a much better user experience, and you can offer net new services and latency sensitive services because the user plane is now closer to where we as humans are actually receiving that service. Now, the other benefit of this entire infrastructure is that we want to be able to enable our customers to be able to have a converged 4G and 5G core for mobile, but we also want to have a common subscriber management experience. So whether you're coming in over a radio, licensed or unlicensed, whether you're coming in over a DSL or PON network, a wired infrastructure, or whether you're even coming in over a cable network, we want to make sure you have a common subscriber management experience and the ability to have common policy for all of your customers, regardless of the connectivity last mile model that they happen to be using. And we think that is not only a significant operational savings, but a great way for you to market new services if you're a service provider in this environment as well. So that's decision number 1. And there's a lot going on there. If we move to decision number 2, this is converged SDN transport. This is truly exciting. Now, if you think about the average speed for a 4G connection being anywhere between 10 megabits and 50 megabits per second. Now with 5G, there's a promise of having 500 megabits all the way up to over a gigabit connection when you're talking about millimeter wave technology. That's exciting for us as consumers, as well as for offering net new opportunities for enterprises and small, medium businesses when you talk about fixed wireless access. But what it means is you have to completely build an entirely new IP and optical infrastructure. And we think that there is a simplified way to do it. We call it converged SDN transport, where you actually can bring your IP network and your optical network much closer to each other than they have in the past. In fact, there's a new technology that will be shipping later this year in the optic space called ZR and ZR+, where you actually can have a transponder in a device about this size, which means that you can then plug that QSFP optic directly into your router, and your transponder is now, without any overhead tax, able to be a transponder plus a router. Now, we think that's going to remove a number of network elements from the network infrastructure. We also think that's going to decrease the amount of power being consumed by your network infrastructure. And it's also going to make it easier to automate that network infrastructure, which means you can offer new services at a much faster rate than you have in the past. Overall, this is extremely exciting for a number of our customers in the space, as you see below. All right, moving on to decision number 3. You see there's a traditional model of doing things done where things are proprietary, it's embedded systems, it's fixed, and it's fully integrated in a single common stack. And that might have been okay 5 or 10 years ago, but it doesn't work for the way that networks are deployed today. And what we see coming is this whole new transition towards a more open environment. It needs to be disaggregated. You need to make sure you are software defined, a software defined radio. Yes, it is a thing. You need to unbundle the software so you can procure the software differently from the hardware, which means your costs will come down as well. It needs to be programmable. You need to be able to address and have new applications and new types of services that you can offer across this, what gives you the flexibility that you've never had before. So what we have done is we have built a whole layer of software, orchestration software, that helps the world's leading companies that are going down this O-RAN or vRAN path to be able to do it in a time-sensitive way. There's a lot of intellectual property that goes about being able to make sure that these technologies actually work seamlessly with each other. Overall advantage, you want to reduce your vendor lock-in. You want to have choice between your hardware radio vendor and the rest of your RAN vendor software. When you have an open infrastructure, we've seen innovation be spurred dramatically. The radio space needs that. Now, not only that, but what our customers who've deployed this have told us is that it's 30 to 50% less expensive, not only from a CapEx perspective, but from an OpEx perspective as well to actually deploy and manage this. Now, it goes all the way back to why we're all here. It's a much easier network to automate as well. Now, those new services and applications, you could think about having network slices, which translates means you can have a private network all the way from the radio through your transit infrastructure, all the way back to an application that's back into a cloud service based upon a set of users or based upon a set of applications. That's very difficult today to configure. And this makes the network much easier to be programmable, which is exactly why we're here today with the developer days. Now, there's this whole set of key partners. Some of them are providing that O-RAN, vRAN software. Some of them are providing the radios. Some of them are providing both of that, as well as all the systems integration around that to bring it to market. And here are a few of our key partners that we've been working extremely closely with on this critical initiative for the entire marketplace. Now, when we pull all these things together, we start talking about what's needed from a cross-policy domain perspective, visibility, and of course, control. Now, in the future, I think there potentially could be 3 different domains for 5G. One is the consumer network. Obviously, we're all very familiar with it. We carry around one or more different mobile devices. In the future, there's going to be a lot of devices on the 5G network with IoT. And we also think that there's going to be a whole set of applications and services for the enterprise, from the small, medium business all the way up to the Fortune 100s. Now, what do they need? They need low latency services. They need IoT services, and there's going to be specific services for things like gaming. There'll be specific services for automating infrastructure, for warehousing, and there'll be a continuation of private networks for things like mining, simply moving from 4G to 5G, where instead of having people on site actually moving the machines, you might have someone in another city completely actually operating the heavy machinery to make it safer for the humans versus having someone in a big vehicle driving around a mine. There's a whole set of use cases. Now, I talked about the ability to extend policy across these different use cases, regardless of whether you're coming in through a Wi-Fi network, a licensed spectrum access, DSL PON, or Ethernet. We want to do that with something we call the Unified Domain Center, which can be integrated with our IoT control center, and also can be integrated into our enterprise use cases through DNAC, which is our intent-based networking software managing intent for the entire enterprise portfolio. Now, this is something we're very excited about. We've been talking about this for well over a year and a half. We've got a whole set of demos and use cases on what you can use with this, and I recommend you talk to your nearest Cisco sales representative to learn more about what we're doing in these exciting use cases. Now, I've been saying this literally for years, but my true belief is that automation is key to the internet for the future. It's not just about new silicon, it's not just about new hardware, it's about how we can simplify and bring all of these elements together, create a level of software abstraction so that you can go and create net new services which enable you to grow your revenue, which enable you to dramatically lower your overall cost, not just to deploy new infrastructure faster, but dramatically reduce your costs for being able to actually automate and operate the network. But it also reduced your cost for going and getting new customers. Because what we've seen is when you fully automate your infrastructure, your customers are happier, and happier customers, they don't churn. They don't look for a new service provider. It's human nature. And then finally, the third key area where automation is key is, of course, to enable you to mitigate risk inside of your infrastructure. So you can know in an automated way, in an immutable source of truth, that your network infrastructure is secure, is trustworthy, and you can go and actually offer net new services across that infrastructure with the right level of trust. Okay, now, as part of all of this, you all know, but I'll say it anyway, NSO is critical to our automation portfolio and critical to our automation plans, not only now, but in the future as well. It is a key piece of technology that enables us to abstract all of the configuration and provisioning information for literally hundreds of devices, and not just obviously Cisco devices, but I think the team has continued to do a phenomenal job over the past several years in making sure that we stay vendor agnostic, so that you can go and provision competitive devices to Cisco as well. And as you all are likely aware, we've got something called ConfD with a number of our network vendor competitors actually have integrated into their products as well, which actually simplifies NSO integration into that portfolio. You know, we've seen you have over 170 different devices, platforms, or OSs supported. We have over 200 customers using NSO today. And one of the things that's really exciting to me is all of the top 10 service providers in the world use NSO in production. This is not something they're doing in a proof of concept or something they're doing over in a corner of their network. This is something that's very broadly and widely adopted. And you should all be very proud of what you have built on top of NSO, but also the potential for what is going to be capable to build on top of NSO in the future. And with that, I just want to end with a huge thank you to the entire community for what you have built around NSO. It's truly amazing to see all the different applications and services and automation happening with this platform. I want to make sure that you know that we are going to continue to invest in all of the tools and resources necessary to make sure that we're able to support all of you as developers to become more productive with this tool. And if you're not getting something that you're needing, please do let us know. We are here to listen. And as part of that, let's go ahead and head on to the Q&A section.
Hi, everyone. My name is Victor Leon, and we have to take a few quick questions. So first of all, Jonathan, you talked a little bit today about what this means for the industry and what that's moving, but what does this mean for the individual developers and network engineers that work with this? What kind of changes will they see as we move through these trends?
So great question. Thank you, Victor, and excited to be here with all of you today. You know, this actually puts the developer in control, in my opinion. The trends that we're seeing across, you know, from hyperscalers to service providers to large enterprises is just simply the ability to do significantly more as an individual than you ever have before. And that puts just a tremendous amount of not only responsibility, but also a tremendous amount of power in your hands as well. And so having these tool sets and tool chains available to you means that you can transform what used to take hours or days or weeks to get done, and you can get these things done in a much more rapid period of time, which frees you up to actually then, from my opinion, go and look at more ways to generate revenue generating services.
That's very good. So you talked a little bit about mobility and the things we do in mobility. How do you think the SDN movement changes and helps unlock artificial RAN space? Do you think, what do you think we have to do with the SDN controllers or that to get that control deeper into the RAN space? Do you have some kind of view on that?
Yeah, so great question. And I think there's really two things to think about. One, the traditional RAN is a closed ecosystem in two ways. One, it's a closed ecosystem because of how it's been traditionally deployed as a closed embedded system with a very small number of players that have dominated the global deployment of this technology space. And so the ability of ORAN is to create open interfaces, to create more flexibility, to create more innovation. But that's just really the first part. The second part is, now that it's more software-driven infrastructure, you now have the ability to open up the licensed spectrum to new use cases and new opportunities. And people have been talking about the ability to do slicing across the radio network. That's exciting. But when you think about it, it's not just slicing is an esoteric word that people are like, I don't know what slicing means. That's what I hear from people. But think about it this way: if you were able to have your own private WAN across the public spectrum, licensed spectrum infrastructure for your customers, for your employees, for certain applications, that is exciting. And there are companies out there today that are deploying private 4G networks. Typically, it's mining companies and things of that nature. It's very expensive. It's very difficult to deploy these today, and so they only get deployed in the most critical of circumstances. I think that there's an ability. You think of slicing, really just think of it as your own private network. And guess what? In the network today, you've got private networks running across MPLS. You've got VLANs inside of campus networks. You've got these things inside of using VRFs inside of public networks and private networks as well. This is just an extension of that. It's just another way to build a virtual private network across publicly licensed spectrum infrastructure. And to me, that's exciting. And think about the types of applications and services that you could offer. Think about, as an enterprise, what kinds of services and applications you might want to take advantage of in that scenario.
That's excellent. I don't think we had any more questions. Feel free to ask more questions in the chat of the app for the rest of the event. And Nicklas, are you ready to present the next speaker? And unless there's any closing remarks.
Yes. And I'd like to, thank you, Jonathan, for a very interesting keynote. It was very interesting to hear. And thank you, Victor, for moderating this. So after a short message from our partner Dataductus, we will welcome Matt Hayes, Senior Executive Director of Cox Communication, up on stage. So let's go to the transition.
At Dataductus, our developers can help you automate the NSO service lifecycle. This includes not only provisioning, but also testing of provisioned services, correctly setting up usage and billing, automating handover to assurance, setting up SLA monitoring for provisioned services, and analyzing and fixing network issues through NSO Automation. For more information, contact nso@dataductus.com.
Greetings, everybody. I'm happy to be here for NSO Developer Days. I'm Matt Hayes, the Executive Director of Network Automation and Shared Services at Cox. Just to jump right in, give you guys a little bit of our company profile. So Cox Communications is we're the third largest MSO that's a multi-service operator, or otherwise also known as cable company in North America. And this is just a little bit of our financials. I mean, Cox is an $11 billion revenue company. Commercial services is a big piece of that, and we have, you know, about just north of 6 million high-speed internet customers. You know, of course, we're a video, voice, you know, and a home automation company as well. But that's just a little bit about Cox, where we sit. One of the things that I wanted to talk to you guys about is a change that we made in terms of how we engage with Cisco professional services and how they have helped augment our own internal staff in terms of how we use BPA and NSO. What's important to note is we've had BPA and NSO in our network for a number of years. But up until about June of 2019, we were operating it in a much different approach, and we needed to make some changes. So some of the changes that we made is we went to what's called a factory development model engagement with Cisco. And previous to that, our operating model was that we had, you know, basically every new automation feature functionality was looked at as a individual statement of work. So in the engagement, I would say, from the, you know, network engineering and operations teams was not really direct contact. We were going through some of our own internal IT teams to identify kind of priorities, and then those were then communicated from the IT team over to a Cisco development team. And you know, with each statement of work, there was supply chain involvement in terms of, you know, the overall process, and it was very cumbersome, and frankly, it was not very effective. So one of the changes that we made is we really integrated our teams. Really, the development, we have development architects, we have software development teams from Cisco Professional Services, and they're really directly in contact with our network engineering and operations teams to help deliver on really a lot of, you know, business cases in our pipeline to deliver these things has greatly improved over the last 10 months. So with this representation, you know, of all these different resources here, you can see it's really an integration. There's Cox, you know, members involved in this team, but the structure that we have and the partnership that we have is really, you know, like we're operating like one team. Additionally, this is a little bit of the functional components, like that team, that sort of organization, you know, people, you know, and role process chart that you just saw previously. This is really more a functional view of that team, and some of the things that we think are most important, you know, into having a productive and effective network automation team. You know, some of the things that are really important to us is that we want to create a network automation that is reusable. You know, we want to create network automation that is standardized. You know, anytime we have, you know, a different use case, whether it's a software, like a software upgrade process, we wanted to create real consistency, whether it's a CMTS or a metro router or a backbone router. One of the things that we've done in terms of the approach that we've taken is we've really adopted a lot of the scaled agile framework in terms of how we do demand management, intake, and prioritization. In fact, we've got every Tuesday, we've got a 1-hour call with all of our stakeholders that includes, you know, includes the development team, it includes the architect, it includes the project managers, but it also includes really an opportunity for anyone within our network engineering and operations team to submit a request for a potential automation use case. And in that forum, you know, we you know, talk about the potential value of it. We talk about any, you know, specific integrations that would be required in order to make the most effective, you know, automation use case. And then we really help shape, you know, what that automation solution will look like. And that's been a really effective forum, because we've got all the right players there that can help sort of, either challenge the use case or help flesh out and develop the use case. And then I would also say that that's also really helped. We've got a good understanding on the back end of how what the overall demand management capability looks like. One of the things that I wanted to share is really the hops. I'm sorry, the way that we leverage BPA and NSO. We put all those two components into a box that we call hops, and that's really not to confuse anyone, but that's just our own internal code name for how we've labeled the network automation platform that is BPA and NSO. But one of the things that's been I would say powerful is just the number of integrations that we have. We don't view network automation, and I know a lot of the people in this conference and in this community, we don't view network automation as really just simply how we interact with devices on a CLI. We're not just trying to automate things that are done through CLI. We're trying to actually use network automation to change, the business process. And I would say the reason that Hops has been more successful for us is because it's connected into our Remedy, our UET ticketing system. It's connected into Atmos. Atmos it's really just it's a mobile application that our field service technicians use. So they can, bar scan or barcode scan in devices that really triggers the whole auto provisioning functionality. But of course we had to integrate with Atmos in order to unlock some of the power of BPA and NSO. Additionally, we have integrations with IP control. That's our entire IP management database. And then Granite for us, that is an inventory management system. So without those integrations, we would still end up with network operations folks kind of swivel chairing into, our IP database or swivel chairing into, our Granite database to go enter in new devices that we've turned up. But as we've started to adopt some of these use cases of zero touch provisioning and, software upgrades, pre and post checks, we can update things immediately right into our UET ticketing system. And basically the Hops platform does that as part of the workflow. When we're turning up a new device, Hops will do the order entry of that new device into our inventory management system. So these are the really kind of game-changing capabilities that we've got in place today with Hops. And like I said, it's because it's tightly integrated with some of our back end, BSS and OSS systems that's made it powerful. And then on the left side of this diagram here, that's really just connecting to our network infrastructure. So you see hub router, RPA and DPA. Those are really data center like switches that connect into our access network. And then the CDR8s represent our CMTS platform, which is connects all of our our 6 million high-speed internet customers to the rest of the internet. So left side of the chart is really all the network components, our network infrastructure effectively that Hops communicates with. And then down below, SmartFi is really it's really like an element management system for cable access. So for CDR8s and for the RPDs, that's remote PHY devices is what RPD stands for. But there's really all those components are tied together to create network orchestration. And one of our primary focuses for the use of Hops, and I would say the initial use cases, has been in the cable access network. But we're certainly starting to identify opportunities where we can reuse some of the benefit that we have in our commercial services network and in our metro network as well. So some of the key features that have been delivered to date, and this is really just over the course of the last 10 months, we've implemented pre and post checks on all of our CMTSs and our hub routers. So really we leverage that and execute that anytime we go into a maintenance. Whether it was a software upgrade or maybe it was a quarterly update, change in an access list or any kinds of things like that, we run these pre and post checks. And it's really been a big time savings effort for us. Not only time savings, but it's also when you think about when you leverage network automation to do pre and post checks, now you gain a level of precision in work that just shouldn't be done by a network engineer, a human network engineer. The automation platform can run these things much more effectively. Running the pre and post check, doing the diff, and then populating anything that's interesting into our remedy ticketing system so that we create this trail for that as well. And then another big one that I touched on really briefly was this provisioning and really consider it like a zero touch provisioning of a remote PHY device. In remote PHY devices and cable access, they're a big deal, in terms of the volume and the number of these devices that we have. Remote PHY devices, they sit in a clamshell that hangs on either a telephone wire or a dog house, which is like some of those green dog houses you guys have seen on your front yards or in the neighborhood. But there's thousands of these things that we're intending to deploy. We'll end up deploying at least 60 to 100,000 of these things in the next couple of years. So as you can imagine, they're not the types of, just given the volume, it's not the kind of thing that you want to have, a field service technician connecting his laptop to in order to provision, right? Because there's a lot of IP information in this. There's associations to which video service groups and cable service groups it's associated with back in at the head end. And it's a relatively complex device. So what we've done is we've built, an integration with this Atmos mobile app. So our technicians now the process is our technicians will, basically barcode scan in the physical device that they're hanging. They'll use a drop-down menu and associate the name of that device. And then, BPA and NSO in the back end then go and orchestrate all that with SmartPHY, with our Granite, inventory management system, and with our remedy ticketing system that then goes and activates this device on the network and provisions all the flow through provisioning through the CMTS, all the security configuration that would be required, all the IP configuration that's required for it, and basically churns up this device on the network. It's an operation that happens, within a minute from them sitting there. So it's really been an effective win for us in terms of validating and showing some of the investment back that we've made in this network automation platform to really changing and optimizing our business operations and processes. Another one that has been a big win for us is just in terms of our OS upgrades. So CBR8, that's our CMTS, and NCS is our metro routers. We typically go through a software upgrade 2 to 3 times a year across those platforms. We've got about 800 CMTSs. We have, I believe, about 550 NCS routers and growing. So the operation before was, we opened a ticket, we had a network engineer, manage the software upgrade process, following a PDF or a Word document that was basically a mop that was crafted by another, design and sustaining engineering team. and the process was quite cumbersome. I mean, just the amount of time that it took to go through an OS upgrade for our CMTS platform was in the 3 month time frame, right? So we were kind of continuously in a cycle of OS upgrades, and there might be a 3 to 5 month gap between the next OS upgrade cycle that would have to happen. We still have to work through and optimize some of our business processes, but we've basically taken a lot of the, that MOP and, fit that into a workflow within BPA and NSO. So now we're executing software upgrades, not only with greater precision, but with a reduced burden and time on the engineer that has to operate those. We're still using an engineer to operate those OS upgrades in case something goes awry, but the number of simultaneous upgrades that our engineers can do within a single maintenance window, I mean, we're probably somewhere in the order of 7 to 10x of what we could do previously when it was just, basically an engineer managing a MOP through the CLI. Just a couple of things on the horizon, and this roadmap is, fairly cable access centric in terms of the different, use, like network automation use cases that we have. But zero touch provisioning, one of the more recent, the near term focuses is around zero touch provisioning for these RPAs and DPAs. And those are really, think of those as like, top of rack switches within our data centers. But we're deploying, as we deploy, tens of thousands of remote PHY devices, all of those require, 10 gig Ethernet connectivity in the head ends to connect those back to the network. So as you can imagine, the RPAs, that's the remote PHY aggregation device, and the DPAs, which is the digital PIC aggregation device. All those switches, we're deploying those, in the hundreds and thousands of devices as well. And guess what? They all look fairly cookie cutter, and they make a good use case for doing a zero touch provisioning. That's some RPD. So we're looking at adding another supplier of our remote PHY devices. So, as we think about those as a little bit more commodity, it's important for us to be able to turn up, and evolve really the cable access network that we've built the automation around. But there's an awful lot of development too as you move into mid-split configuration automation. So what that means is one of the things that we're looking to enhance our network is growing the upstream capacity. So the idea of moving the spectrum to create more upstream bandwidth, we've got to reallocate, downstream versus upstream frequency in terms of how our cable access network is architected. And as we're enabling mid-split, there's a lot of work that has to happen up front to do that. But the fact that we can build, automation capabilities, again, reusing some of those components like we talked about the mobile app, we're going to have our field service technicians going out and removing a bunch of, bypass filters and things like that in the outside plant. And when they're ready, all they need to do is basically go in and use that mobile app to scan in the remote PHY device again. And we're going to reuse a lot of the same components that we did to build RPD activation. We're going to reuse those to create the capability to enable the mid-split, which is going to jack up the upstream throughput that we'll be able to offer for our customers. But again, it's a network upgrade. If we didn't have network automation capability to do that, there'd be an awful lot of phone call coordination between the outside plant technicians, the field service technicians, our network operations center, and then our network engineers who are back, banging away on a CLI, reconfiguring the CMTS. So those are no longer required now. We're able to do all this with, reusing a lot of the same, underlying and foundational work that we built around RPD activation to enable this mid-split capability. Yes, I got another thing. The last thing I'll point out, relative to this slide is, we're also looking at as we're turning up XGS PON, so that's a 10 gig variation of PON. We're looking at doing a zero-touch provisioning, very, very similar to what we did with the RPDs. And there's a lot of similarities. The 10 gig OLTs that we're deploying, they come in a clamshell. The same team that deploys the remote PHY devices is going to be hanging these things on a wire or in a doghouse. We're going to reuse, again, a lot of the same functionality that we built around scanning in the device and then having BPA and NSO, effectively our HOPS infrastructure, do all of the, provisioning of that OLT. So that's another, sort of big win that we're looking at as we roll out 10 gig PON. We currently deploy GPON, but our intent is to upgrade that to all 10 gig PON for all new greenfield that we build in the second half of this year. So this is just a look at, it's a little bit more of an exhaustive look at some of the feature functionality that we're looking at pipelining and building within HOPS. But I don't want to sort of drain this one, but I guess I'll just leave this in here for reference in case you guys want to have it as an artifact to go back and take a peek at. But I think the important thing to point out here is that this tool it started out with a clear focus on cable access, and I talked a lot about CMTSs and remote PHY devices, but really we're expanding beyond that, in trying to build success in other areas, right? Like we have, data center, we have metro, we have the PON access network as well. There's a lot of different, wins that we know we can identify in other areas. So here you can see in this particular case is basically the RPD activation case. And it's important for us to do that because, as we're asking for continued investment in some of these platforms and in the labor and the teams that support these things, we've got to be able to tie back that, the real business benefit. Some of them are obvious, but even if they're obvious, we want to be able to illustrate them with, consistent measures. So, we're looking at anytime we have time savings, anytime we have, precision gains or, more reliable network, we want to try to be able to associate those to something that makes business sense. So that's all I really wanted to illustrate in this last slide here. But no, I think it's, I guess just in wrap up, overall, I've been really excited to be a part of the network automation team. In fact, when my team first inherited sort of a leadership role with BPA and NSO just about a year ago, I was in a different role. And for myself and my team, through the time, I would say that some of the success that we've had here, and how our leadership understands just the role that network automation is going to play for our future, we've had an organization change, and now my role used to be focused in the access network, and now my role is focused in network automation. And I have a team of folks that are focused just on network automation. So I think that's really been a testament to some of the success that we've had, but also how, as an organization, we believe it's network automation is going to be a really important part of our future and how we think about network operations. And we've got a lot of commitment from our leadership, and we're continuing to build momentum in that. So anyways, excited about the journey, excited about the opportunity that BPA and NSO has already created for us, but also some of the future that we think is bright with BPA and NSO moving forward. So yeah, happy to open it up to any questions from there.
Hi there, Matt. Great presentation, really come a long way with your automation. So when you've done your automation, when it comes to skills and the staffing, have you found it a hard time and to make the transition, find the right competence for your team?
Yeah, good question. I mean, there's certainly a bilingual component to a network automation engineer, and a few of my folks are here on at NSO Developer Days, but the traditional background for a network engineer, specifically at Cox, you came up and you cut your teeth through the CLI and you learned the different technologies. We are having to really retool a skill set, but there's definitely a group of folks who are eager to learn and pick up some of the new capabilities and technologies, whether it's learning an Ansible skill set or even learning more about development through Camunda and workflows within BPA. It's definitely, we think of it as kind of bilingual engineers are the most valuable ones, the ones that understand, network operations and even specifics of, how networks were operated previously. But it's a skill set and a muscle that we're trying to grow, and it's going to take time. I mean, I think we've got a great start, but we think about it really, as a culturally too. I mean, we're trying to build a community practice around around network automation. So we're trying to create opportunities to really grow the muscle and take the folks who have taken the first steps at adopting it and learning the new technology to help lead others.
That's great. So what kind of roles do you primarily have in your team? So do you mostly have network engineers that are transitioning to more of a software architecture role in the automation, or do you have pure software engineers as well?
Yeah, we're really building a lot of the team structure, around software development, and scaled agile is one of the models that we like, where we put some of the program structure around intake and demand management, but then also agile, and Scrum kind of based teams to do the software development. In the engagement here that we have with BPA and NSO, I mean, we are fairly heavily leveraging the partnership for some of that agile and development team, but looking to grow some of that internally as well. We want to be able to move towards self-sufficiency, in terms of keeping up to date life cycle of some of these automation capabilities, but also growing new ones.
That's good. So how does this affect your network, and what kind of metrics do you see changing as you introduce more automation? Do you see an improvement in efficiency and things like that?
Yeah, absolutely. It's I mean, we're, like I was talking about in the presentation there. I mean, we're developing really sort of a common approach to how we analyze and measure the return on investment for the different automation use cases that we're developing. And those things are, network precision, their data integrity, of course, their time savings, and it's like we're not just changing the way that we interact with the network, we're changing the overall business process. So we're trying to tie back all those things into financial measures to really keep the investment growing, and to make sure that our leadership and our finance folks are aware of the investments that we're making really do tie back into OpEx savings.
Okay, thanks a lot. I think that's all the questions we had. Maybe Nicklas can take it over.
Yeah, so thank you very much, Matt. It was an interesting presentation on Cox Automation journey, and thank you, Victor. So we still have a minute to go before next session, so I just would like to promote using the chat in the session. So you click on the session, and there you find the chat. You can ask a question. We had some issues in the beginning, but we're all learning since this is the first time we have this virtual event. We also have this game. So the more you use the app, the more points you will earn. and there will be a leaderboard that you can see where you are. We have partners in here. Look under the sponsor tab. You can go to their landing pages and find QR codes and scan them, and that will give you even more points. So, and end of this event, we will post the winner for this contest on Developer Hub. So I urge you to do that. So, so after this short message that we will have from one of our partners, we will welcome Fredrik Jansson up on the stage. Fredrik is heading up the CTO team within the BU, and he will talk about how NSO is used for 5G slicing. So yeah, thank you.
Hi and welcome. My name is Fredrik Jansson, and I'm here to take you on a journey through 3 different domains and explain to you how we built a proof of concept for 5G end-to-end slicing. Before we start, I want to give a quick shout out to John Maluli and Victor Leon. Without the 2 of them, this proof of concept wouldn't have happened. With that said, let's move on. So the key takeaways from this is that I want you to take with you is that NSO is the best tool for implementing domain controllers, and that NSO is also a brilliant tool for implementing cross-domain orchestrators. I also want to say, don't forget about the resource manager for NSO, and you will see why during this presentation. The example that I'll use here is around 5G end-to-end slicing in a 5G for enterprise example, but I want to stress that the same techniques we used here can be used to solve a wide variety of cross-domain problems. So first, what do we mean by network slicing in this context? Well, network slicing is fundamentally an end-to-end partitioning of network resources and network functions, so selected applications and services may run in isolation from each other for a specific business purpose. So with that out of the way, let me explain what you see in this picture. To the left, we have the RAN side. I will not go into any details of RAN here, but we do need to configure the RAN PE as part of the transport domain. We have a separate data center for the 5G control plane where we run the 5G apps. The enterprise network is a VPN that we assume exists in the service provider network. And then the idea is to deploy a UPF for a customer in a given SP or enterprise data center. A UPF is a user plane function, which is basically the data plane for wireless. So this is where the GTP tunnel coming in from the RAN side is terminated. And this is also where, for example, a cell phone's IP address is anchored. So while your cell phone can roam between different cell towers, the IP address actually is anchored at the UPF. From the UPF, we need to make sure we have connectivity with the right cost parameters or SLAs. Going to the RAN side, we need to go to the 5G control plane side, and of course, we need to take the data from the cell phone or equipment through the UPF into the enterprise networks. And over the next slides, I'll go through the 3 different domains, data center, transport, and 5G control plane, and highlight each domain's challenges. After that, I'm going to switch over and I'll present how we address these challenges using NSO and friends. So in the service provider enterprise data center domain, we typically have multiple data centers that can be geographically spread. We typically have a fairly complex MANO stack that could, for example, be ACI or plain OpenStack, which we use in this proof of concept. Given the connectivity requirements we have for the UPF, we also have a somewhat complex network that needs to be built. The UPF in our case has 4 different networks connecting to RAN, enterprise network, the 5G control plane, and then we have a separate management network for NSO. And as something could go wrong either in the VIM or with the UPF, we also need to handle healing of the UPF in this domain. So let's switch over to the transport domain. The transport domain typically consists of a fairly large network. This is typically part of the SP core network. More often than not, we have a mix of Cisco and third-party equipment in those networks. The P routers that we need to configure as part of the transport domain typically have a fairly complex configuration. And then on top of that, to fulfill the different 5G slice types, low latency, high bandwidth, encrypted link, and so forth, we need to deploy VPNs or segments with the right cost requirements. Then we move into the 5G domain, and this was probably the most challenging for the proof of concept. So let me explain to you what happens here. As a background, the Cisco 5G packet core control plane is deployed as cloud-native applications. In the proof of concept, we are running it on top of Kubernetes. And as part of this proof of concept, we also wanted to show that we could automatically deploy vanilla Linux VMs and then install the Kubernetes cluster on top of those. So as those VMs were spun up, we needed to coordinate with the SMI cluster manager, which I'll touch more upon later what that is, to tell it to deploy Kubernetes on those vanilla Linux VMs. When the K8s cluster is up, each application first needs to be deployed, and once it's deployed, it needs to be configured. And I want you to remember that these applications are spun up and spun down on demand. And it's also further complicated by the number of different applications that need to be deployed in different combinations for different customers and different use cases. So for example, you see that there is a PCF, a policy control function, and an SMF, a session management function, deployed as part of a URLLC, ultra reliable low latency, which I'll refer to as a low latency slice. So there we have a dedicated PCF and an SMF for a customer who needs low latency. In the IoT use case, we are opting to use an existing PCF, a shared policy control function, but having a dedicated SMF per IoT customer. This is really up to the service provider how you want to package that. But this adds to the complexity. As the applications are deployed, they need to be correctly configured for each use case. So these 4 slides has hopefully given you some insight into the challenges that each domain presents. So let's switch into how we address these challenges using NSO. Again, we're going to start in the data center with the data center NSO. And as mentioned before, in the DC, we need to be able to handle multiple data centers. We also need to deploy UPFs with their somewhat complex networking. And once the UPF is up and running, we need to make sure we monitor its health. For this, we are using the Cisco MANO stack, which is NSO NFVO, the Elastic Services Controller, ESC, and Cisco VIM. With the ESC, you can actually choose to have one ESC per VIM or let one ESC manage multiple VIMs. And this flexibility of ESC really simplifying deploying the UPF or any VNF for that matter in the available data centers. Using NFVO on top of ESC allows us to hide a lot of complexity around deploying, creating the right networks, and also configure healing of the UPF. Even though it's ESC that is actually monitoring, we need to configure it. We also make heavy use of the resource manager to allocate VLANs and IP addresses for the UPF for the different networks that we create. I also want to highlight that we do actually not onboard the UPF as a device in this domain, but we actually onboard it in the 5G NSO, which I'll touch upon later. Everything here is made into a domain-specific service that we expose to the northbound. And that is a concept that we have reused across all the domains in this proof of concepts. And we could actually have chosen to expose the NFVO as it is to the cross-domain orchestrator. But we do think that by having a domain-specific UPF, in this case, service, actually gives the organization that is responsible for this domain much more control over what can be done from the northbound. And it also simplifies the consumption of this service from the cross-domain orchestrator. So simply by adding the right abstractions, we give both the organization responsible for the domain more control, but we also make consuming the service a lot simpler from the cross-domain orchestrator. So with that, let's check out the transport side. Here on the transport side, we can potentially have a large set of devices from different vendors. And this we attack as always using NEBs. And I know that this is no news for you, but this allows us to configure Cisco or third-party devices. We are also using the TSDN, the Transport SDN core function pack, which is built to scale, which we need in this domain. But it also adds abstraction on top of segment routing. And that allows us to build the correct or right SRTE segment routing traffic engineering policies. For example, again, for low latency, high bandwidth, and so forth. In this domain, we also need to configure BGP, as the UPF needs to communicate with RAN, with the RAN side for the GTP tunnel. It needs to get the traffic into the enterprise network for the detunneled traffic. And it also needs to communicate with the 5G data center, as it needs to communicate with the 5G control plane, specifically the SMF. Again, we are using the resource manager here to allocate route targets for VPNs, specifically for those VPNs that we create on the fly as the services are deployed. And in this case, the domain-specific service takes IP addresses and VLANs that is actually coming from the data center side into this domain as input parameters. And so with that, let's move into the 5G domain, where there are a lot of things going on. So hang on. In this domain, we use SMI, Subscriber Microservices Infrastructure, more specifically the cluster manager part of that. The cluster manager is used both to deploy the Kubernetes clusters, but also used to deploy the different 5G control plane applications onto those clusters. So it really serves us two purposes here. SMI comes with conf embedded, which is a huge win for us, as we get netconf, of course, we get notifications. On top of that, actually all the Cisco 5G applications come with conf embedded. Again, a win. You get netconf, we get notifications, and those two really simplifies the integration to NSO. These conf-tiers are typically referred to as ops centers, and not only do they provide netconf, they also provide CLI, RESTconf, and other northbound interfaces to the cluster manager and to all applications, in case you want to consume this from something else than NSO. Notifications are used both by the cluster manager and the applications to tell NSO what state they're in. So using these notifications, NSO knows, for example, that PCF is now 50% deployed, now it's 100% deployed. And that allows us to write the services in NSO to actually sit back and wait for the application to say, hey, I'm now 100% deployed, and then we can start configuring that application as we would configure any device in NSO. And here in this domain, we actually onboard the UPF that was spun up in a different domain, but we actually onboard it as a device here and configure it as part of the slice. We also built a domain-specific service that simplifies the adjacencies between the different applications that we have. So, for example, that service allows us to express that an AMF can have multiple PCF, and a PCF can have multiple SMF, and an SMF can have UPFs, and so forth. So it really gives the cross-domain orchestrator a simple way of expressing for URLC, low latency. I want to deploy a PCF, and with that, a specific SMF. Or, for example, in the IoT case, I want to add a new SMF to an existing PCF. Here we use a resource manager to allocate IP addresses for the application, and also to allocating slice differentiators, which are coming from the 3GPP side, and are a way of identifying the different slices in this. So let's move into the last domain. So in the cross-domain orchestrator, we built a couple of example services, for example, URLC, low latency, EMBB, enhanced mobile broadband, which is basically high bandwidth or consumer wireless. And these services are super simple. They take 3 or 4 parameters, including in which data center you want to deploy the UPF. And once that request comes in, the cross-domain orchestrator goes to the data center and say, hey, please deploy a UPF in New York, for example. And at the same time, it will go to the 5G control plane and say, for URLC, I need you to deploy a PCF and an SMF. And once those requests are sent, the cross-domain orchestrator waits for notifications coming from the southbound. And once the UPF is spun up in the data center, that NSO will send a notification up to the cross-domain orchestrator saying, hey, I now have the UPF running in New York. It's ready. It has these IP addresses. It's up on these VLANs. And once the cross-domain orchestrator has that information, it can start proxying, for example, the VLANs and the IP addresses down to the transport side, and it will send the IP addresses down to the 5G side, where we now can configure the SMF and the UPF to have connectivity. They need to know about each other to establish the link. And the same thing on the transport side. It needs to know the VLANs to build the subinterfaces, and it needs to know the IP addresses to set up the BGP connection and so forth. And it also knows from the cross-domain orchestrator what kind of VPN is needed. Is it a high bandwidth? Is it a low latency? And so forth. So all of this is really driven in the cross-domain orchestrator by setting configuration and reacting to notifications from the lower NSOs. Finally, I just want to say that I typically don't see the cross-domain orchestrator as a master over the lower domains. I rather see it as one of the consumers of the services offered by the lower domains. And I also want to mention a really cool feature that you get, and that is fast map across domains. So it's well known that we use fast map within each NSO, but now with fast map across the domains, we can, without any specific code, allow a user to come into an existing low latency service and say, hey, I want to move the UPF from New York into Atlanta. And the cross-domain orchestrator will see that the only thing I need to do basically is go down to the data center and say, hey, move New York UPF to Atlanta. And once that is done, again, through FastMap down there in the NFVO, we'll talk to the right EC and spin it up. We will again get a notification saying, hey, UPF is now up and running in Atlanta. The cross-domain orchestrator will pick up the new IP addresses, potentially the new VLANs, and send those down to the SMF through the 5G domain and down to the transport to rebuild the VPNs, the slight rebuild that we need to accommodate the new UPF in the new location. So fast map across domains is really, really cool. So how does this apply to you? Well, I would argue that you should start small. The key is really to divide and conquer. Start looking at solving one domain at a time. Work on getting good abstractions in the service that you expose. Try to abstract away as much as you can. This makes it a lot easier to consume it from the cross-domain orchestrator. And this is really where things like the resource manager can help by allocating as much as possible down in the domains and kind of hiding that complexity from the cross-domain orchestrator. And then you can use the built-in primitives in NSO, like service plan change notifications and notification kickers and so forth to drive this flow in the upper NSO. So thank you for listening to me. I will, thank you for listening to me. I will now be available for questions. Thank you.
Battling a smoke detector. So I am winging it for Q&A. So Fredrik, let's start with the basic. There's a lot of cool capabilities and technologies we talked about. How do I actually buy this? Is this in a neat little packaged box? Where do I start? Kind of what's the guidance for folks that are really interested in this and want to try applying this in their environment?
Well, so the 5G function pack that I touch upon is something that we're working on at the moment. We are aiming to have a first release out of the core function pack in the October timeframe, and happy to answer more questions on around that if you want to reach out to us through your account team.
Sure. Yeah, absolutely. For all these things, reach out to the account team. I think most of the speakers are also available through the app, so you can chat with them directly. Nicklas also wants to make sure that you guys are answering the polls question. So while you're between questions, please answer the poll. You can see the results from the poll once you answer. So Fredrik, you talked a lot about cross-domain, and it certainly seems that's very central to what we're trying to do here. What are some of the challenges when you're trying to orchestrate across multiple domains like this?
Well, I mean, there are multiple challenges, right? Each domain poses its own challenges to itself, as I said in the presentation. But then to really utilize the domain controllers, if they're NSO or something else, you typically want to build an end-to-end service sitting on top of that. And typically in a perfect world, you could just send the intent everywhere and it would just work out. But it turns out that you really have to spin up a VM like we do here and actually wait for that to come up before you can proceed. I think that is still a challenge that we have. I think NSO does a great job helping you solving that problem through notifications and nano services and driving that forward. But I think that was the biggest challenge we had in this proof of concept, was really make sure we orchestrated the domains that we had.
Sure. So, and one of our claims to fame is multi-vendor orchestration automation with NED. So is it safe to assume if there's a NED or we can build a NED, we can work that gear into an end-to-end slicing scheme, or are there other things that we need to be paying attention to, or are there other restrictions?
No, I think if we can build a NED, we can, if we can talk to that domain controller or that device through a NED, in a perfect world, it can generate notifications to us to drive it. If that's not possible, we can poll it. So I think as long as we can talk to it from the cross-domain orchestrator, we're good.
Cool. And we're talking not just specific hardware, right? We can we can control other controllers, maybe some even cloud-based resources, those kinds of things. So there's potential a lot of flexibility here. Okay, cool. So along those lines, I know we're also all about netconf yang and the like. So is this restricted to netconf yang? Can we manage other types of things? And along those lines, do we see netconf yang being more widely adopted as customers go to 5G and start a refresh cycle for their hardware?
I mean, absolutely, yes. I do think we're seeing netconf taking off in many different domains. Foremost, of course, still in the transport domain or for the routers and so forth. But I mean, again, all our 5G applications that Cisco built, including the controller for that, the SMI. Cluster manager, all come netconf ready, and that really simplifies the integration with NSO. You basically get integration with NSO for free. You get the NEDs for free. They can generate notifications, which makes that driving I touched upon earlier really simple. But again, I want to stress that other vendors may not have that, and again, as we said, as long as we can talk to whatever that is through a NED or something else, we're good. So it helps, but it's not the only thing.
Cool. So I know you've spent a lot of time talking to customers in terms of developing the solution to that point. What do you see as their leading use cases and their kind of biggest challenges around moving forward? And for the folks that are watching, what can they learn from the customers that are kind of the cutting edge of this?
Good question. I think the one way to take away from this is really the effort we put into making each domain easy to consume. I think that was one of the key things. Abstract away, use all the tools that we can provide around NSO or tools that you have to simplify the consumption of this.
Okay, cool. And prior to the release of our core function pack, the access, any other reading, any other things customers can be doing to come up to speed? Who else should they be talking to organizationally? I mean, this is not just an infrastructure thing. It ties into other parts of the business. What other conversations do we need to be having from a process perspective?
You mean to get into something like this yourself?
Yeah, I mean, who else? I mean, within the organization, right? It's not just setting up the infrastructure. Should I be talking to service creation folks? Is there, should I be talking to the OSS, BSS folks? Who are the other stakeholders when you turn up something like slicing, from your experience talking to other customers?
Oh, okay, great question. I mean, so just in this, right? It's a proof of concept, but I mean, we were touching about on 3 domains in here. So you would have to talk to your core networking guys. You would have to talk to your data center team about, in our case, spinning up the UPF. You would have to talk to the team responsible for your packet core, if it's a 5G, 4G use case. And then, of course, this has to be consumed by an OSS and BSS system. So all those teams would have to be involved one way or another. But again, I'm keep falling back on the domains, and I think again, you can work with each team and have each domain present an API that the cross-domain orchestrator can consume. And you as data center team, for example, can really make sure that is an API, that is the API that you want your internal consumers to use.
Okay,
Yeah,
makes sense. Last question, and this is, you get to opine. This is an easy one. So we've talked about this specifically from a service provider perspective, but do you see enterprises using slicing directly as part of the way they deliver apps, or do you see it always being a behind the scenes thing a service provider provides to their customers?
No, so again, I can't say I'm a 5G expert, but I mean, we do see enterprise use cases for 5G in mines, in factories, what do you call those, like PG&E type of companies, utility companies. So I think there will be a lot of interest in 5G from enterprise companies as well.
Okay, cool. Well, thanks, Frederick. I think this was very cool. I think that's it from here. Back to, I think, Nicklas. I hope.
Thank you, Omar.
Yeah. Very good. Thank you, Frederick. That was great to hear those insights on the 5G slicing. And thank you, Omar, for asking those questions. I see that the activity on the event app is coming along nicely now. We have had some issues on the poll and chat, but do keep posting questions on the chat. And if you want to share your home environment on the activity stream, there are posted mine so that you can see how it all looks like. So we will have a short message from our partner Devo team, but first I want to just talk about the next step here. So next step, you will have about 5 minutes to log on to the live track. Those are WebEx sessions, and you have the link on a separate tab. So continue to engage using the app during those live tracks, and after that you can continue basically how long you can on consuming the on-demand content. We have hours of on-demand content, and when you finish up, fill out the event survey. If you want to join us tomorrow, you can do that tomorrow as well. But yeah, those are the steps. So let's go over to our message from Devo team.
At Devo Team, we have many years of experience in delivering network automation, service fulfillment, and assurance solutions. We help organizations of any size that are striving to make their infrastructure more agile, reliable, and cost-efficient. Automation is the key for simplifying network operations. It should be done by adopting modern interfaces and DevOps practices. Automation is a journey. Let's begin.